Hello students, welcome to our third lesson in Senior Secondary 2 Physics. Today, we'll dive more into the concept of speed, velocity, and acceleration. But before moving ahead, let's take a moment to revisit what we covered in the last lesson. In our last lesson, we explored speed, velocity, and acceleration. We also identified speed as a scalar quantity, while velocity and acceleration are vectors. We went further to calculate resultant velocity using examples. And I hope you learned something. Before we dive in, let's look at our lesson objectives. By the end of this lesson, we will understand the differences between speed and velocity. We will also be able to identify and interpret velocity time graphs, and understand instantaneous velocity and acceleration. Let's get started. First, let's break down the difference between speed and velocity. Speed is defined as the rate at which an object covers distance. Speed is a scalar quantity, which means it doesn't involve direction, just how fast something is moving. The formula for finding speed is speed equals distance divided by time. For example, if a car travels 60 kilometers in 1 hour, its speed is 60 kilometers per hour. On the other hand, velocity is the rate of change of displacement. Displacement refers to the shortest distance between the starting point and the ending point, along with its direction. Velocity is a vector quantity, which means it includes both magnitude and direction. The formula for velocity is velocity equals displacement divided by time. For example, if a car travels 60 kilometers north in 1 hour, its velocity is 60 kilometers per hour north. It's not too difficult. Now, let's look at velocity time graphs. These graphs show how an object's velocity changes over time. It is a useful tool for analyzing motion and understanding patterns of movement. The components of velocity time graphs are x-axis, which represents time, measured in seconds. The y-axis, which represents velocity, measured in meters per second. Graph lines, which indicates how velocity changes over time. Let's take a look at key patterns of motion represented on graphs. These are 4 key patterns to understand. First, uniform velocity. This is shown by a straight horizontal line on the graph. It indicates that the object is moving at a constant velocity, with no speeding up or slowing down. Next, uniform acceleration. This appears as a straight, upward sloping line. It means the object's velocity is increasing at a constant rate. Then, we have variable acceleration. This is represented by a curved line on the graph. It shows that the object's velocity is changing at an irregular rate, meaning the acceleration isn't constant. Finally, instantaneous velocity. This is the velocity of the object at a specific moment in time. On the graph, it's represented by the slope of the line at any given point. By understanding these patterns, we can analyze an object's motion more effectively and interpret the details of its movement. Interesting, isn't it? Let's explore instantaneous velocity and acceleration. Now, instantaneous velocity. Instantaneous velocity refers to the velocity of an object at a specific moment in time. It tells us how fast the object is moving and in which direction, right at that exact point. It is a vector quantity, meaning that it has both magnitude and direction. Magnitude in this case means speed. For example, imagine a car traveling north at 40 kilometers per hour at 10 a.m. with a speedometer that reads 40 kilometers per hour north. That's the car's instantaneous velocity at that moment. Moving on. Instantaneous acceleration refers to the rate at which an object's velocity is changing at a specific moment in time. It shows how quickly the object is speeding up or slowing down. Well done, you're doing great. Now, let's see how much you've learned. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Great job so far. Let's take a moment to recap what we've learned. Speed is a scalar quantity that tells us how fast something is moving, while velocity is a vector quantity that includes both speed and direction. Velocity time graphs help us analyze motion and can be identified by their patterns. Instantaneous velocity is the velocity at a specific moment, while acceleration measures how quickly velocity changes. In our next lesson, we will be learning about simple harmonic motion.